Good morning, student. I am Ashish Verma. I am assistant professor in civil engineering department in Asst Engineering College. My teaching subject is RCC. So today's my topic is doubly beam. So according to earlier video, we discussed about the according to the placement of the beam, which is the two types, semi reinforced beam and doubly reinforced beam. Today we discuss about the numerical on doubly reinforced beam. So numerical is this. So calculate the ultimate moment of resistance of an RCC beam of rectangular section is 300 mm and 400 mm. Area of steel of rod is 6 number of rods, 18 mm dia at tension side and 3 rods with 18 mm dia at compression side. Grades are given Fe 4 and 5 M20 and cover is 25 mm. So first of all we write the given data. Given data is width of the beam 300 mm and depth of the beam 400 mm. Area of steel which is denoted by Ast, 6 number of rods into pi 4 and dia is 18 mm square. So 18 square is Ast, and here is another rods is given which is the compression side, 3 rods with 18 mm compression side. So this is the area of compression zone, so which is denoted by Asc. So here is 3 rods and circular section area is 5 for d square. So here is dia is given as 18 mm. When you calculate this Ast, you got the value of Ast 1526 mm square, and Asc when you calculate in the calculator you got the value nearly 763 mm square. So we draw the diagram. This is my beam whose width is 300 mm and all over depth is 400 mm, and cover is also given, which is covered as cover length is 35 mm, and this is a compression zone. This is the tension zone. Here 6 rods, 18 mm dia. Here 3 rods, 18 mm dia is given in numerical. So this is a compression zone, this is a tension zone, and 3 rods, 18 mm dia here is used. So 3 rods we can draw it. Here is 6 rods. And grades are also given, which is Fe 4 and 5 and M20, and cover is also given. Cover is denoted by d 35, and here is all over depth. So we calculate the depth only. So capital D minus cover of cover. So all over depth is 400 mm and cover is 35. You got the value 465 mm. This is a small d. This is the depth of the beam which is above from the cover vision. When you minus this value, you got the value 365 mm. So we calculate this, we find the ultimate moment of resistance. So we proceed this numerical according to the steps. So design steps for this numerical. First of all, step number first, we calculate the actual neutral axis. Actual neutral axis which is denoted by Xc. Its formula is X equal to 0.87 F by Ast minus FSC Asc upon 0.36 FCK B. Here is 0.87. F is the grade of steel, Ast area of steel, FSC stress in steel in compression zone. This is the FSC, and Asc is area of steel in concrete 0.36 is the value. FCK is the grade of concrete which is M20 and B is the width of the beam. When we put the value in this formula, so you got the value. When you put the value into the formula, so x equal to 0.87, f by the 415, and AST area of steel 1526, and FSC 352.75, and this is the area of steel in concrete 763.36. FCK is the grade of concrete which is value is 20, and B width of the beam is 300. So 352.75. How to get? So this is the formula of FSC, 0.85 into f by which is given in a numerical is 415. So when you multiply this value, you got the value 352.75. That's how you got the value. This. When you calculate this value, you got the value nearly about 132 mm. This is the value of actual neutral axis. So step number second is critical neutral axis, which is denoted by XU max. So its formula is XU max equal to 0.48 D. This formula is valid only if the grade is Fe 405. If this grade is Fe 250, so its formula becomes 0.53 D. If this grade is Fe 500, if this grade is Fe 500, you got the value of 0.53 D. If this grade is 250, you got the value of 0.46 D. This is a Fe 415, and this is a Fe 250, and this is a Fe 415. This is a Fe 500, 0.53 D. And if this Fe 250, so condition is 0.46 D. If this Fe 415, so formula is 0.48 D. So here is numerical, we given data is Fe 415. So we applied the formula is Fe 415. So apply the formula Fe 415 when 0.48 and depth of the beam is 365. When you calculate this value, you got the value of nearly 175 mm. This is the XU max and this is the XU. Earlier video we discussed about the section of the beam, which is sections are under reinforcement, over reinforcement, and balance section. Here is XU max is 175 and XU is 130 mm. So which condition is followed? There XU max is greater than XU. Critical neutral axis is greater than actual neutral axis 175, 130. When this condition is occur, this is a under reinforcement section. This is the under reinforcement. You can call this step number third. This is step number third. So here what we find ultimate moment of resistance. So this is the step number third. We got the value. We got the section which is under reinforcement section. So now we calculate the ultimate moment of resistance of the beam. Ultimate moment of resistance which is denoted by capital M of suffix R. Its formula is 0.36 FCKB XU B minus 0.42 XU plus FSC ASC D minus DS. This formula of moment of resistance in WB for MR equal to 0.36. FCK is the grade of concrete which is 20. And B is the width of the beam which is 300 mm. And XU value is 130. This is the XU max. This is XU. Depth of the beam is 365. minus 0.42 130 plus FSC value 352.5 and ASC what 3 ASC what 763 and D is again 365 minus D dash. When you calculate this all value, you got the value of MR 176.36 into 10 to the power 6 Newton mm. This value is got when you calculate the movement of resistance. So here is we calculate the ultimate movement resistance. The ultimate movement of resistance value is coming this 176.36 into 10 to the power 6 Newton mm. I hope you understand very well. Thank you so much.